All right, today we are going to talk about logarithms, and we're going to talk about them a bunch. And logarithms are one of my favorite things because it's one of those things in math where if you understand why it works, how it works becomes a lot easier. So, logarithms and exponents are kind of like opposites. So, if addition is moving forward, subtraction is moving backwards. Same is true of logarithms and exponents. So, let's go ahead and start with some drawing. So, normally, when we do an exponent is a base to a power. And if you understand both of those, that will give you a value. Logarithms, meanwhile, on their end of stuff, they do stuff a little differently. So a logarithm still has a base, but that base is beside the logarithm. So when you're reading a logarithm, this is log base of. So logarithm base number and then of. And that of is of the value. So basically, excuse me, sorry about that. So basically, take that exponent, slap it on the other side as a logarithm. And when you do that, that will be set equal to a specific power. So if over here on the left, we're asking, okay, this number times itself, how many times gives me what? On the logarithm side of things, we're saying, okay, so I have this number. How many times would I have to multiply the base by itself to get that number? And that is your answer. So in the case of, let's do something simple. So let's say 3 squares. So 3 times 3 is 9. So base of 3, power of 2, value of 9. Okay, fair enough. Let's turn that into a logarithm. So then we'll have logarithm. So we have a log whose base is 3, whose value is 9, and whose power is 2. So if how many 3s do I need to multiply in order to get 9? Well, I need 2 of them. And that is how you are supposed to evaluate a logarithm. So this, how many times, gives me that. That's what a logarithm says. So to give a little bit of a messier example, because sometimes we have clean examples and then we have messy examples. So this is our formula still. So we're keeping the same formula. Ooh, got a little bit over there. Okay. So we're keeping the same formula. So let's say I have something like 10 to the 4th equals x. Okay. Or actually, no. Let's change that a little bit. So 10 to the x equals, let's say, 1,000. Okay. So let's say you don't know what the power is off the top of your head. That's okay. Most people wouldn't. So then we can do a logarithm. So the logarithm, so our base before was 10. So our new base is going to be 10. The value, aka what it equaled to, that was 1,000. So that 1,000 is going in here. 2, 3. And that equals x. So now we've turned a variable in the power to a variable that we can solve for. And this is what logarithms are really good at. Whenever this is a variable, we can just figure out what it is using a logarithm. So in this case, the question being asked is how many 10s do I need to multiply in order to get 1,000? Well, 10 times 10 is 100, so we need to go a little bit farther. So times 10, okay, so 10 times 10 times 10, that's 1,000. So this logarithm is actually just 3. So x is just 3. So 3 to the, or I'm sorry, not 3 to the third, my goodness. 10 to the third equals 1,000. Which is what the original question was asking, albeit in a bit of a strange way. So we are going to use this information, the ability to go back and forth between logarithms while keeping exponents in mind as a way to help us figure out, well, what else can logarithms do? Because they can also do some other weird stuff. And we will be exploring that weird stuff. But for right now, for that little tidbit, we're good on that. So let's go back. So, we got logarithms. What are they? How do they function? And of course, we just talked about how to read them. So the base is what you need to get the value. The value is the number you're multiplying to. And the power. So we just went over all of that. So we can skip this slide real quick. And now let's talk about power rule. Okay, so power rule logarithm's got some interesting qualities. So what we're going to do is we're going to talk about those qualities now. So as we just discussed, so log base 3 of 9 equals 2, or equals a proper 2. So, and we know that this is true because how many 3's do we need to multiply in order to make 9? Well, we need 2 of them because 3 times 3 equals 9. So that's why the logarithm would be 2. So we know that this is true. We know it's true. And we also, let's do another one. So let's say log base 3 of 3. So, quick question for you. How many 3's do I need in order to make 3? Correct. I only need the 1. So if I have a single 3, I have a single 3. Fair enough. That is also true. So now I'm going to do something a little bit different. Let's say I multiplied both sides of this equation, which we know to be true, by 2. So multiply the left side by 2, right side by 2. So that would mean that 2 times the log of 3, or log base 3 of 3, is equal to 2. Okay, coolio. So there's one other thing that we need to keep in mind. So we're going to mark this as true. There's one last thing we need to make sure. One thing, we've already kind of agreed on it, but 3 squared is 9. 3 times 3 is 9. So this is also true. This is true. Okay, so with all of these things in mind, we're going to do a little bit of substitution here. We are going to take these 3 pieces of information and put them together to figure out a logarithm rule all on our own. So real fast, we know that this is 2, this is 2, and we know that this is the same as 3 squared. So what I'm going to do is I'm going to start over here with this guy. So I'm going to write log base 3 of 3 squared. Okay. So we know that 9 is the same as 3 squared. We know that that's true. That's why I put this guy here instead of the 9 we had before. I'm writing it as 3 squared. I'm doing that for a very specific reason. Okay, so with that in mind, we know that that equals 2. We also know that 2 times log base 3 of 3 is also 2. So if this is 2 and that's 2, then we should be able to set them equal to each other. And it just so happens that, we can write 9 as 3 squared. Well, that's pretty neat. So now I'm going to clear the board a little bit. Just a little bit. Just a little tiny bit. Oh, dang it. Too much. Just a little. I keep hitting that logarithm up there. I need to stop that. Okay. So then just a little tiny bit. Okay. So now we're going to look at this guy for a second. We're going to look at him because he's pretty interesting. So this is 2. And this is 2. So 2 equals 2. Congratulations, we're doing math right. All the logic lines up. So now there is a certain pattern here. And if you want to, real quick, I want you to pause the video and try to figure out what's the big difference between this guy and this guy. If you spot it, that's awesome. If not, that's okay. So go ahead, pause, maybe give yourself, maybe 20 seconds. See if you can spot it. See it? Okay, so here's what's happening. So all of these numbers, and both of these logarithms, are the same. So we're 3 for 3, we're 3 for 3, except there's one difference. The power in here is 2. There's no power in here. But this number here is 2. That's interesting. So everything is the same, except the power seems to be out in front over there. If you said that, you're absolutely right, because with logarithms, if there's a number out in front, you can make it the power. And if there's a power, you can make it the number out in front. So if I had, say, logarithm, say log base 10 of 5 to the x. So this looks pretty awful. Having a power as x kind of stinks. It's kind of stinky. But logarithm rule says I can put the x out in front. And it's like, oh, okay, cool. So now x is just, multiplied by something, right? Because log base 10 of 5, all of this is just a number, and it's a number that I can divide by, or I can multiply by, or I could add or subtract whenever I need to. But now the x isn't a power anymore. That's awesome. So this is just something to keep in mind when you're doing logarithms, is if you see, you know, a power inside of a logarithm, you can always just slap that thing out in front, and now you don't have to deal with it as a power anymore, which is a very, very nice property that logarithms have. This is called the power rule of logarithms. And here, I will formally write it, color coordinated, of course, so that you have it for reference. Okay, so if you have a logarithm with some base, it of course has a value, but it has a power on the inside. So if you've got that, then you can move that power out in front and keep the rest of the logarithm exactly the same, just with the power out in front instead of on the inside. And you can also do this vice versa. So if you have a power out in front, you can make it the power on the inside, and you can make the power go on the outside. It's a very neat little trick. You can do it both ways. This is the power rule of logarithms. Again, just to state it for posterity. Okay, so that was pretty nice, and we were able to come up with, you know, most, if not all of that, just by playing around with some logarithms. This is the kind of stuff I enjoy doing sometimes. It's just learning more stuff by just playing it around a little bit. And this basically says the same thing. If there's a value, if the value is written with a power, you can make it the coefficient. Coefficient just means number in front of the logarithm. And if there's a coefficient in front of the logarithm, you can make it the power of the value. So yeah, you can go forward and backward with that. Is basically what that's saying. Okay, so now product rule. Product rule is a little bit strange. It's a little bit strange, but we can explore this. So it's kind of like exponents, but backwards. And I know that doesn't make much sense right now. So let's go ahead and switch to the board, and I'll show you what I mean by exponents backwards. So let's say I've got log base 3 of 9 plus log base 3 of 9. So we've already talked a little bit. That is to, you know, from the previous example. But there's another logarithm I want to show you real quick. So, by the way, 9 times 9 is 81, right? That means, so that's 3 squared times 3 squared. So that would be 3 to the 4th. Nice. So instead of writing 81, we could write 3 to the 4th. So real quick, so log base 3 of 81. So this basically says that 2 plus 2 equals 4. I know, complicated stuff, but we're getting there. We're getting there. I'm joking, of course. 2 plus 2 equals 4 is very simple. But the important part here is that because 3 to the 4th is 81, that's how many 3's we need to make 81. So that would make the logarithm's value 4. Which is good, because that means that logically we're being consistent. 2 plus 2 is in fact 4. Sometimes you just got to make sure, you know, sometimes you make a little mistake and you write something off and it's like, wait a minute, 2 plus 3 isn't 5. Or I'm sorry, 2 plus 3 isn't 4. That's weird. But anyway, so 2 plus 2 is 4. Okay, so this is another one of those cases where there is a pattern. So I want you to go ahead, pause the video just for another couple of seconds and see if you can't figure out what the pattern is before I tell you. So look at what's the same, look at what's different, see if you can spot the pattern, and then unpause the video and I'll go ahead and tell you. Okay. All right, you guess? Okay, cool. So all of these guys are the same except for their numbers on the inside. So log 3, log 3, log 3. So we need to keep a consistent logarithm base the whole time. That applies for most of these rules. But what's different is these numbers. So we got 9, 9, and 81. So is there a way that we can link 9 and 9 that would give us 81? Why, yes, there is. As a matter of fact, we can multiply 9 times 9 equals 81. That's neat. So what this means is that if we have logarithms, right? So if we have logarithms with some base, and they've got, and they're added. So they have the same base and we're adding them together. Then we can just multiply the insides. So log base b of a times c. And it works like this every time. This is called the product rule. The product rule. Okay, so and the reason it's product is because you multiply what's on the inside. So if we are adding our logarithms that have the same base, we can just multiply their insides and make them one logarithm. Pretty straightforward. So now I'm going to write the start of the next rule, and I'm going to give you a chance to guess and see if you can figure out what the next rule is. And by the way, if you don't guess correctly, that's okay. Not everybody always does. So product rule means if we add the logarithms with the same base, we multiply what's on the inside. So real quick, if adding means we multiply the insides, what do you think subtracting means we do to the inside? So adding means multiply. Subtracting means what? Go ahead, pause the video, take a little guess, and then I will double check with you to see if you were right. Okay, you guessed? Okay, cool. So this is the quotient rule. It's quotient rule. And for those of you who know what the word quotient means divide. So if you said that we divide the insides, you were 100% correct. If you didn't guess, that's okay. I just have a lot of students that are able to figure out from the product rule what the quotient rule does. If you didn't, that's perfectly fine. There's nothing wrong with it. Just remember that adding two logarithms with the same base means you multiply the insides, and subtracting two logarithms with the same base means that you divide the insides. As long as you can remember that, you should be fine. So I'm going to go ahead and pull up two examples, one of the product, one of the quotient, and we'll do both of them together. So let's say we have log base 9 of 3 plus log base 4. Oh, I'm sorry, log base 9 of 4. My apologies. What should that logarithm look like? What's its base and what's its value? Go ahead and try it for yourself. Pause the video if you need to. You got it? Okay, let's double check. So we got log base 9 of 3 times 4. 3 times 4 is 12. So this is our final answer. Yay! Okay, so now let's do one more. So we got log of, let's say 25 minus log of 5 equals... Oh, and by the way, in case you're wondering, if you do not see a logarithm, you are supposed to assume that the base is 10. So if you see a bunch of questions where there are logs, but there's no bases written anywhere, assume it's base 10. Base 10 is the number system that we work off of in modern mathematics. So for most people, if you say you're doing base 10, it's kind of like, oh, yeah, well, of course you're doing base 10. We teach base 10. So just know that if you don't see it, it's supposed to be base 10. Fair? And then go ahead, guess what the logarithm is. Pause the video if you need. All right, I'm going to go for it, so you better pause if you want to check. All right, so we have log base 10, because they didn't specify, but I will. So log base 10 of 5, and it is 5 because 25 divided by 5 is in fact 5. Good job. Well done. If you didn't get it, that's okay. This is an example to help you learn with. We'll have plenty of questions in the independent practice for you to work with. So in the meantime, let's jump back over to the presentation and see what we got next. Okay, so product rule, quotient rule. Haha, we already did the quotient rule. We already did that, so we know what that is. And that's the end. Now we're at the logarithm stuff. So here is the the logarithm question that we're going to be doing whenever we do the synchronous hours. And so yeah, I'm gonna leave this one to you guys. Best of luck with it. And I'm excited to talk to you guys about logarithms. I really like logarithms, so it's just one of my favorites. But anyway, that is all for now, and you have an awesome day. Bye-bye.